Hello everyone. Okay, a state of pure confusion. I'll just get straight into it. I think good advice in general, and especially good advice for programming, is to approach your solutions by asking, first of all, why? Why are we doing this? Why are we taking this approach? How are we going to do things? And then, that leads into the how. How are we going to take our approach? And then finally, the what. There's some very good TED Talks on why, how, what, but we often have this temptation to just run in and write code. One thing that I get very excited about is talking about code. Yeah, it's a good way to waste time as well. This talk has been affected, there's my picture, yeah. This talk has been affected a lot by a project that I've been very involved with for several months, supporting this project. And it's really had a big impact on this talk. For a long time it's had a code name, but we've been in production for 4 weeks now, yay. And I'm actually talking about my baby, yeah. So, a state of pure confusion. If you're familiar with functional programming, purity and statelessness are clever puns, and this is a dad joke, but actually this is just an autobiography of where I'm at the moment. And this is rare, this is more common. At 1 a.m., 2 a.m., 3 a.m., 4 a.m. But what I want to get into is mostly to talk about why. I know it said I was going to talk about jargon, but just cutting things short. The jargon is more the what and maybe the how, but let's just focus on the why. Why do people do medium post after medium post about this thing called functional programming? Some people say that JavaScript is a functional programming language. Other people say, no, are you serious? Others say it's a multi-paradigm. I don't really care how you want to categorize the language. I really care about why. What is the motivation? What is useful about it? And the major selling point for me, and I think for you too, should be how functional programming helps our understanding of why we're doing things, how we're approaching them, and then finally what code gets spat out at the end is sort of the end result. Do we understand everything that happens in our JavaScript programs? And how can we be certain? When I was a younger JavaScript programmer, I used to answer, of course, a lot faster. These days, having written JavaScript for a long time, I'm more and more reluctant to say, yes, I fully understand everything that's happening, especially on a larger code base. And when people say, yeah, I know everything that's happening, I usually like to question, do you really? And this is where functional programming tends to come in. If you talk to some groups or some meetups, or you watch some videos online, there seems to be this impression that functional programming, particularly when you get into the hardcore languages, when you find out what Rob really knows when you pick his brain, when you start to talk about Haskell or PureScript or all these things, you see that there's an entire world of language, an entire world of jargon, an entire world of these difficult concepts. But through all of this, unfortunately, sometimes in the community, not always, there's a veneer of smugness, for lack of anything else. And that smugness comes from a claim that might seem outrageous, might even seem unfair, but sometimes it's true. And that's the claim that I actually know what I'm doing and you don't. I actually have confidence in every single thing that's going to happen in my program and you don't. Now, I don't really buy that entirely. Even a well-architected functional program, you might have more confidence about things like your functions and things like your modules, but overall, if you've got a complex system, it's a complex system. Minor things like how you describe your functions are not going to get you out of that. It just might help you with things like testing and all that kind of thing. But here's some jargon, because I promised some jargon. Monad, monoid, currying, that's probably a popular one. Functor, composition, ADT, high-kinded types, partial application, applicatives, semigroups, and the list goes on. All of these, as we had that talk on jargon, unfortunately sometimes can obfuscate things, can make it seem inaccessible, but many of them are concepts designed to provide us with clarity. And I'm not even going to go into explaining a semigroup or an applicative. That's really not the function of this talk. I just want to look at a bit of why. And instead of looking at functional programming in detail, I just want to look at what we know as JavaScripters. And one thing we do know, whether you consider yourself an object-oriented person or whether you consider yourself a functional programmer or somewhere in between, one thing we know is tests. And when it comes to this issue of do we know what's really happening, we write tests. Tests are one way that we can get a sense of control back into our world. There's entire approaches, TDD, test-driven development, and I'm not here to disparage tests. But to the functional programmer who sees someone relying on tests, they'll often point out this point. Do our tests fill us with encouragement, or do they ever leave us wondering whether we've missed something out? Have you ever thought, okay, I'll write a test, all right, what could happen? Well, I think this could happen or this could happen. 6 months down the track, you find that, hey, I didn't think that could happen, and you failed to write the test. I've certainly done that many times, not just in JavaScript. And if we think about functional programming, I think I've shared this slide once before. We test functions like this. You've got an add function, and without the wonders of flow, you might first want to test that it's actually a number. A is a number, B is a number, and you return A plus B. Very, very simple, right? So we test these, but why don't we test simple statements like these? There's nothing different from here to here. It's still just JavaScript. But implicitly, we all know that this is not the kind of thing you want to bother to test. And for lack of any other good reason, I like to ask why. Why? Why don't we test if true doesn't equal false? Or 1 plus 2 as literals equals 3, or even if we've got a constant like n, and then immediately if n equals 3. Why don't we test? And the basic answer that we all know intuitively is because this comes as a guarantee of the language. So the level we're at in JavaScript is a language, and it provides some strengths, some weaknesses. As Rob pointed out, type checking is not one of the strengths, and we end up trying to come up with approaches to get around that. But one thing we do have is the strength of simple things we trust. And when we trust, we don't test. And that brings up a scary idea that as much as I'm in favor of testing, each and every single time you ever write a test, you're making a confession. If you're writing a test, you're making a confession that you don't actually know for sure everything that's going to happen. Every single time, it doesn't matter if you're writing C# backend code or JavaScript frontend, every time that we do testing, there's a reason why we do it and there's a reason why we don't do it. And that's when, if we're going to be honest, we're saying, I confess, I'm not sure if this is really going to do what it's supposed to do. And there's nothing wrong with that, I still write tests. But again, coming back to this one, it is disparaged and even laughed at sometimes by functional programming. In some areas of the community, I don't think we should give out tests. But we do need to know that every time we write a test, we're also making a confession. And knowing that's a good thing. It's good to know what you don't know. These are satisfaction guaranteed. So today I just thought we'd look at a simple function and ask the question, what do we really know about a function? We use them everywhere. It's the bread and butter of how you make JavaScript work. But what do we really know for sure about a function? You know, I think we really know for sure, correct me if I'm wrong, that true doesn't equal false. But when it comes to a function, what do we really know for sure? Do we know things like the values in, the bindings, the values out, this types, effects? Functions in JavaScript are very flexible. We can pass them around. A lot of languages, even statically typed languages, don't have this kind of flexibility. We can create things like higher order functions, and we can pass them as callbacks. Functions in JavaScript are objects, and you can shove a bucket of properties on top of a function. They're very flexible, but with this flexibility comes a lot of responsibility. Maybe you don't believe me. So here's a fun example. This is possible in JavaScript. Const x equals get x. What is x? Maybe it's the number 7. Maybe it's hello world as a string. Const x equals get x. Const some object equals get object. So what is the object here? If we're listening to Rob, we know that it might not actually be an object, even though we say it's an object. And that's where we can add type annotation. But assuming that we believe it, we've got x is getX, maybe a number, object is some object. Let's do something kind of simple. This object has a property A, and here I've said, does A equal X? And maybe I'll log that out to the console. And JavaScript says true. So if A is 7, what must X be? It's not a trick question. 7. Or if A is hello world, X must be hello world. In fact, we're dealing with constants here. We're not changing the references. What about object B? If object B is 7, X is likewise 7. And then we do something like this. And it's entirely possible, and I've seen it more than once in production code. If A is X and B is X, it should be matter of fact that I can log A and I can log B, compare them, and it should be true. But in fact, in many cases, if you want to do some dirty things, it can be false. I can think of 3 main ways that this can become false. In traditional JavaScript 5, you've got the getter-setter. So you can always inject a listener at this point, and at the point of getting, you can perform a mutation. And you might change B to B10. A great new feature came out in ES6, and that's called proxies. And there's a lot of great stuff you can do with proxies, but again, it allows for this kind of mutation. And then finally, if you've got some asynchronous events happening, or if this is promise bound, probably not in this example, you can also do asynchronous mutating values, even with constants. So, certainty. I remember this once. If we come back to our test function then, I'll make a new function, add AB, and we've got an object with object A, object B. And I've written some tests, just like we had before. Is the type of A a number? Is the type of B a number? Alrighty then, let's return A plus B. Can I trust this code? Most of the time, if you've got a sane developer, you can. It's pretty rare that you can do these kind of exotic things. I like to do as much exotic stuff on the weekend as I can. But here we have an example where we forgot to write a test. And who would do something so maddening? Well, I would. And here we have a result maybe that you don't expect. So when we come back to our humble function, testing is a confession that there's a lot we don't know. The fact that we try to install type systems over the top of JavaScript is also a confession that we don't know a lot. And even though functions are what we do as our bread and butter all day, every day, I think it's sobering for us to step back and just remember there's a lot of stuff we don't know. First of all, this.go. How many arguments does this.go accept? This, hey, I had a typo, there you go. Arity, or now it's length. Arity is the name for the number of arguments something accepts, and we don't know. Maybe with a type system you might. Likewise, the parameters coming in. You don't have to call a function with all the parameters. This is something we encounter early on, sometimes even in GA, and sometimes to our surprise. Not only do we not know if they're coming in, we don't know what they are. Not only do we not know what they are, yep, one second. Here we're calling a parameter called this. And this is the magic parameter. So you might pass in A, B, C, D, E, F, G, and no matter what, every function gets another magic parameter, just for fun. And it's often used as a get out of jail free card, but the problem with this is it is difficult to understand. There is a spec and you can get your head around it, but 9 times out of 10, even if you've gotten your head around it, somebody else has had a different understanding when they've been using it, especially when you have more than one person. So this might not be an object anymore. This might be used in a different context. And the simplest of things can change what you think this is. IDoStuff might be called through an arrow function. This has changed. I do stuff might be called using the new keyword as a constructor. This has changed. I do stuff might be called with the bind method or the apply method or the call method. All of these things mutate this value, this. But it's something that comes with every function. Every function in the entire land of JavaScript comes with this. And yet this is probably the most unreliable thing. Let's have a look. Oh yeah, one sec. I was going to say, okay. Likewise, we have another concept if I come back to arity. If we look at this .go. This .go, we might go and look at the docs and think, okay, go is a function that accepts 4 arguments. I'll just call this .go. But I could rebind that function. And when you call the bind keyword, you can pass in some of the values now, and that lets you pass in the rest of the values afterwards. Unfortunately, JavaScript doesn't update the arity. So any function you make, in this case I do stuff, if you go I do stuff.length, it will give you the answer 3. But if I bind AB so that I do stuff is ready only to accept 1 more argument, then I ask, all right, what's the length of this function? How many more do I need? The answer I would like would be 1, but actually it's still going to tell me you need to add 3 things. It's not just when you declare a function, but when people give you functions or when functions are returned from a library. As well, we're not sure with a function what it returns. And this is quite a large topic that I think the next speaker will get onto a lot. In this case, what does I do stuff return? Can anyone tell me?
Undefined.
Undefined, yes. It has an implicit return of undefined. So when I call I do stuff, it's going to return a value undefined, but it's also calling these little things like a.again and this.go. Who's to say that that's not going to print drop tables? Who's to say that that's not going to open my CD drive or whatever? These are the things we call side effects. Is the fact that functions are not required to return anything. Well, they will return undefined, but they can also, as a get out of jail free card, do things we never knew they were going to do. And I guess the basic example is console log or alert. These are examples of side effects where you call a function like the add function, add a plus b, and all of a sudden something over here happened. A value logged to my console, or cross-site scripting is the best way to demonstrate the dangers of sleep. Okay. There's one more thing, and that is d. Some people might have noticed that there's another value here, d. In this case, where is d coming from? I hope somewhere up the top. Doesn't have to be, right? But in this case, I hope it's coming from somewhere external. And what that means is that when you call I do stuff, who knows what that stuff is going to be? We know that we can trust it's going to be based on A, B, and C, if we have A, B, and C. If A, B, and C are what they're supposed to be, we know that it relies on this, if this hasn't changed. We know that it relies on go, if go hasn't been rebound or hasn't changed. And finally, we know that it relies on some invisible scope or context within our function. And one of the greatest issues with this is when we try to refactor and we move these kind of functions into another line of code, and we see all sorts of interesting errors. So the fancy word, if I'll add some jargon, people call this an outside reference. And the goal in functional programming is to get rid of this, instead get something called referential transparency. So if I do sort of a breakdown of jargon, how would a functional programmer respond to all this? Or they'd say, Justin, you're not allowed D, get rid of D. It's not allowed because it's not passed into the function. They'd say, what on earth is this? Table flip. They'd say, where's the type systems? Where's my types? I need my types. And they'd say, why doesn't it return anything? Why is it doing something weird and exotic on the side? Yeah, what can we do about it? There's all sorts of things. There's arity, parameter types, return types. We can avoid this. We can keep purity with referential transparency. they're all the what's, and there's a lot of jargon, a lot of stuff to go into the what's if you want to refactor. But I think for us, if we want to know the smug, if we want to respond to those who kind of smile at us and go, haha, you're writing JavaScript, how can you be confident like me? We do need to start with the point of acknowledging it's a pretty wild world out there in JavaScript. Absolutely every function we ever write, we don't know what it takes, we don't know what it's been called with, we don't know the types, we don't know if it does anything on the side, and we don't know if it gives you anything back. And that's where we begin writing code. Hooray! I do love JavaScript though. Some other things, this is my Nuke talk, is we can, I might just skip that. Just gonna skip this. That was a good slide, that was a good point. Type systems get pretty extreme, but they're extremely valuable. There's entire textbooks like type systems in programming languages, or I borrowed this from my book, Advanced Type Systems Topics in Programming Languages. And finally, because this is a bit more like a lightning talk, there's Google. I'll just skip to where I want to go. Functional programming is smug. And one of the reasons it is smug is it's very clever. Sometimes almost too clever that you can't comprehend a word that's coming out of someone's mouth. But there is a lot of value that it can provide for us. One of the things is the type systems that you saw with Rob earlier. And I think for anyone who's interested in the Elm talk coming up with Peter, he's probably going to show an example of a functional language. But all I want to leave us with is an awareness of our own faults and the why. Why does it matter? Why did people try to look for something else? Why would you want anything else when you have JavaScript? There's a few reasons, and for us we need to think JavaScript's not going away. We need to be proficient in it. But there are people turning to other languages. In this case, Rob often relies on PureScript. Peter is going to talk to us about Elm, and there is a reason for this, and that's trying to get around some of these challenges that we face in our own language. Thank you. Yeah.